Okay, so this is going to be the first of 3 videos. The first video here I'm going to talk about, okay, video 1 of 3. I'm going to talk about adding forces, okay? So the first thing is forces or adding vectors. Let's say that let's do it so we can do all things. Vectors. A vector is anything which has a size, which is normally given by the length of the arrow that you draw or represented, and an angle, a direction. So vectors have size and direction, okay? When you add them, you've got to take into account their direction. So if we had 2 vectors like this, the vector on the left and this vector I'm drawing now, there are 2 ways to add them. The first way is to do this, and then to do that, and then to do that, and then use the cosine rule, okay, which we know how to do, but we're never going to do it. What we've determined is that we're going to use vector resolution for vector addition. So we're going to do vector resolution. This is what we've done, and this is just a revision for vector addition. Okay? So what we are basically saying is whenever you have a vector, it can be made up of 2 other vectors. Okay? One is its horizontal component, and one is its vertical component. So what we're basically saying here is that this and this represent this. Not all 3 together, it's either this one or these 2 together. Now how do we take the horizontal component from this vector here? Well, we take its size, and let's call it size, just f. It could be z, it could be k, it doesn't matter. And any representative, could be any word you like. And this angle here. Well, we want to find the horizontal component and the vertical component. So we do this. We say, okay, if this is the angle alpha, then the horizontal component is f cosine alpha. Because as I pull this down, I crush this angle. The vertical component, as I move this up, I stretch this angle, is f sine alpha. So every single vector in the world can be composed of a horizontal part and a vertical part. Now, why do we do that? The reason we do that is it's so much easier to add vectors like this or like that than it is to add vectors whose angles are all over the place. So what we do is, if we have 3 or 4 vectors, we find the horizontal and vertical component of each vector. Okay, so if that was 3 vectors, we do that, and then we add them all together. Now this is where we come to use our system here. Let's say this is the addition of just 2 vectors. This is the sum. We get something here and something here. So all these 2 vectors together give us this plus this. Okay, and so this would be the horizontal component, and this would be the vertical component. I've made it negative. It might not be negative. Now, how do you find? So our final vector, the sum of the vectors, is these 2 vectors, but we don't want 2. We want 1. So how do you combine 2 vectors into 1? Now, just notice what we've done here. Up here, we've taken a vector and we've split it into its horizontal and vertical components. Now we've got horizontal and vertical, and we want to put them back together. We're doing the exact opposite thing. Well, what you do is you do Pythagoras. Okay? And it doesn't matter whether this is here or here, it's exactly the same. If I label those sides A, B, C, then A squared is B squared plus C squared. As I know B and C, this I can easily do. The angle can be any angle. It doesn't matter. It can be this one or this one. I always take this one. So tan alpha is B over C. So alpha is tan to the minus 1 B over C. Now that's a very simple way. Now notice this method works with 2 to 22,222 vectors. You can add as many vectors as you like, and it's very simple. That is the basis of vector addition.